Okay, this is Decoding the Human Genome by John Sundberg. I wrote my paper about the human genome and mapping it and its applications. So, to begin, this is what's thought to be an area of the future, mapping the human genome. It was thought impossible anytime in the near future, and even once it began to become possible, it was incredibly expensive. The first map of the human genome cost nearly $3 billion and was done by it was done by the American government in the Human Genome Project. However, since then, some technological advances have been made. Breakthroughs in genomic mapping. George Church developed a device called the Polytron, which has greatly lowered the cost of genomic mapping. He's brought it down to about $1,000 to get a personal human genome map. And that's been made possible through automation. Uh, George Church has been a pioneer of automation in DNA sequencing and ultimately in genome mapping. And all that's made possible through information systems and software. Um, so, having a personal genome map means that you have a full genetic layout of yourself. Now, this can be used for many different things. The first that comes to mind is personalized medicine. Personalized medicine would change the way our medical field works because you'd be able to develop just exactly what someone needs to fight off the disease they have. It would lower side effects. It would lower the need for antibiotics for as many problems. It would do wonders in our ability to fight off disease and other problems. Another field that having a personal genome map opens up is nutrigenomics, and that is the study of nutrition based on genetics. What that means is by knowing someone's genetic structure, you can determine what kind of foods they break down better, what type of diet would be most beneficial to them, if they're likely to have heart problems in the future, if they're likely to have adult onset diabetes. And by knowing that from an early age, you can prevent some of these terrible afflictions just with a healthy diet. And that doesn't replace the need for exercise and eating healthy. I mean, you can't just eat bacon every day simply because you know that you don't break down green beans well. But it can do wonders for our health. And the third field that it opens up is genetic alteration. It means we can actually, at a genetic level, change the structure of genes and insert them, which you could basically, ultimately, the future application of that would be the extension of life, the ability to make someone immune to viruses and the way viruses function on DNA, and many other things. It would also allow us to bring back extinct species like the Neanderthal, the woolly mammoth. And not only would that be interesting to study our history, but they may have immunities to diseases that we haven't even thought of yet or discovered yet. And they may have immunities to diseases that we currently are fighting. So the medical applications of all three of these are huge. And again, all that's been made possible with computer systems, information systems, and automation, as well as innovation. Which leads us to data storage, the most interesting part of this lecture, right? Data storage is key when you have this much information about somebody. You know, with a full medical history, their genetic information, their family medical history, that alone will allow you to determine probably who this belongs to. But also, it's something you don't want falling into the wrong hands for a variety of reasons. I mean, your insurance company, knowing that you have a risk of cardiovascular disease, may want to raise your rates. These are dangers of this kind of information getting into the wrong hands. Also, electronic health records are an obvious way to protect this information and correlate it with any other medical data you have. But again, that leads us back into data protection, the same issue. This is going to be a key field in the future, both politically and medically. And I think it preaches all the more for the purpose of a national electronic health record system that will both protect your genomic data as well as your normal medical history. Anyway, so that is what I've learned in my research on the human genome, its mapping, and the use of information systems in the progress we've made in that field. Thank you for watching my video, and I look forward to watching yours.